Okay, so here's the third question we have today, which is going to be about the spool. Actually, a spool is not like a roller that's going to have the wire to be wound around. So we have a spool and telephone wire wrapped around it, around this core, have a total mass of 80 kilogram, and the radius of gyration is zero point 0.3 meters. So I can find now the IG, of course. If the coefficient of the static friction between the spool and the ground is going to be equal to 0.4, and the coefficient of the kinetic friction is going to be equal to 0.2, determine the angular acceleration of the spool if the end of the cable is going to be subjected to a horizontal force of 30 Newton. I think that we had a similar question earlier in one of the quizzes, and that's just an advanced stage of that. So once again, we have here the core is 0.2 meter radius. The outer one is 0.75. The cable is going out there for 30 Newton. Definitely going to have a normal force here, a friction force in this direction. So we are going to do the free body diagram for this shape. It's going to look like that. The force going to the left, to the right, sorry, 30 Newton. The weight going downward, the reaction force going upward, and the friction force going to go to the right. We are going to find the direction of this one later by the sign. So we are going to have the free body diagram to be sketched, the sigma of the force to the x-axis, sigma of the force to the y-axis, and the sigma of the moment around the point G to be equal to the IG alpha. We can do the sigma of the moment around the point A, and this will give me actually the second part is going to be the force of the 30 Newton multiplied by the distance from the A to the point, let's say B. Now, assume there's no slipping, then the AG should be equal to, therefore we're going to find the NA, the alpha, and the FA. And since that the FA we're going to find is going to be more than the 314 Newton, and this will tell me that no slipping as assumed. So we're going to see that by steps. So go first for the definition. This spool undergoes a general plane motion, and it is not known if the slipping occurs or not, so the assumption is going to be needed, and any assumption must be verified. So we go to the free body diagram. As I told you, I always like to simplify them. Sorry, this one shouldn't be here. So this should be removed, going only on the kinetic diagram. Anyway, free body diagram, we have the weight going downward, the friction force and the P going to the right, and the normal force going upward. At the point A, and we can say this one point B, and this is the center, which is the point G. Now the kinetic diagram only going to have the mass multiplied by the acceleration G, and this will go to the left, and we are going to have the IG alpha as the moment going to the counterclockwise. Now we're going to start to do our calculation by listing first what the known value we have. So we know the mass, we know the rate of gyration, we know the coefficient of friction for the static, and coefficient of friction for the dynamics. So the unknown are going to be the alpha, the NA, the FA, and the AG can be simply be assumed if we're going to have no friction, that we're going to have an AGX. Okay, the direction is going to be related to the direction of the alpha, and the AGY is going to be equal to 0 because it's going to be purely horizontal, so no acceleration going upward and downward. This just rolling, and the acceleration is going to be horizontal. No vertical acceleration is going to be considered at the point A. Now we are going to do the analysis for the three components, the force to X, force to Y, and the moment around the point A. Now everything is clear for us. We only need to do some assumptions. So the first assumption is going to be, under the assumption if no slipping between the spool and the ground, the AGX is going to be equal to the distance from the A to the G multiplied by the alpha, tangential. And this will go to the left. Okay, so now we know what the value of the AGX in terms of the alpha that we don't know how much. The IG can be calculated by using the mass and the radius of gyration. and we're going to get the value to be equal to 7.2 kilogram meter square. Now, under the assumption if no slipping, we cannot use the FA is equal to the static multiplied by the NA. The US multiplied by the NA is the maximum friction force, but the actual friction force in that case is going to be less than this value. Okay, now we're going to go to the forces to the x-axis. Now, if you ask me about that, if there's no friction, if there's no slipping, that means we're going to have friction, but it's not going to be the maximum one. So now we're going to go to the force to the x-axis. So it's going to be the mass multiplied by the acceleration at the point G to the x direction. And it's going to be equal to the P, that's P going to the right, plus the FA is going to be equal to the mass multiplied by the AG to the X. To the Y direction, we have that the force to the Y direction is equal to the, here, we're going to have the negative W plus the NA, and we're going to have on the other side to be equal to the mass multiplied by the AGY, which means that this one is going to be equal to 0. So by solving the first one, we can find a relation between the FA and the AGX. Okay, now you remember that we found the AGX in terms of the alpha, so we can substitute that there. And we're going to find that the AGX is equal to 30 plus FA divided by the mass. And this will give me a 75 alpha. So we got that, okay? And we can start to do the calculation from this point. So now everything is almost ready. Now, by the way, we got that because the AGX is equal to 0.75, I think. So 0.75 multiplied by the alpha. We brought the mass to be divided by the 30 plus the FA, and that's how we got this value. This will be the equation 1 if I get to rearrange it. So the FA is going to be equal to 30 minus the 80 multiplied by the 0.75 alpha. Well, actually, this was an extra step. I don't know why I did that, but anyway, that will be the equation 1. Now we're going to the equation 2. It's going to be equal to the weight negative plus the NA is equal to 0. Then I can find the value for the NA, just equal to the weight, but it's going to be upward. Now we're going to another equation to find the value for the alpha. So I can go to the moment around the point A. IG is known, the alpha is unknown, the mass is known, the AGX is known as the terms of the alpha. The RGA is already being found. Okay, this is from the G to A, or A to G, whatever. The MA on the 3-body diagram is equal to this P multiplied by this from the P to the A. The P is known, this is known, so the only unknown we have here is going to be the alpha. So the alpha is going to be equal to this value. Let's see how we got that. The P DAY, the P multiplied by the DAY was going to be equal to the RS plus the RC, or the 0.75 plus the 0.2, I think. I don't remember. Anyway, so on the other side, this will be equal to the IG multiplied by the alpha plus the mass multiplied by 0.75. Okay, the I multiplied by the 0.75 multiplied by the acceleration at the AG. Okay, so the 0.75 is that distant. Okay, the 80 is the mass, and that's the acceleration G. So we're going to come to this value. We can substitute the parameters in, put the sign to tell me what about the direction. This will take you to the clockwise direction, so it's going to be negative. This will take you to the counterclockwise, so it's going to be positive. And the IG alpha is going to be positive because we consider that will be direction of the rotation. Now, with this equation, the only thing we need to solve is going to be the alpha. So we're going to come out with the alpha value to be equal to negative 0.546 radian per second square. Now I'm going to substitute that in the equation of the acceleration gx, and I'll find that this acceleration is going to be equal to 410 meter per second square. And simply by substitute that in the equation 1, we're going to find that the Fa is equal to 2.76 Newton. Now we can calculate the maximum friction force, which is going to be equal to the N multiplied by the static coefficient of friction. Okay, so the F maximum is going to be equal to 314 Newton, which is more than the 2.76. Okay, so by doing that, we said that our assumption of no slipping is okay. Okay, so again, to talk about that once again in the class, if you have any question, I'm going to be more than happy to answer your questions.